So, good morning, children. Let us continue our topic, that is the structure of hydrocarbons. So, previous session we all discussed about what about the structural formula, and the condensed formula. So now here, if you just see now in front of you, you are able to see some structure. I hope now you must have guessed whose structure is this. So how to identify that whose structure it is? You have to count, yes, the number of carbons. So how many carbons are here, children? 4. So that means the root word of this compound is what? But. And then whether it is a saturated hydrocarbon or an unsaturated hydrocarbon, that how can I identify? By checking the type of bond. So here you see everywhere there is only a single bond, so that means it's a saturated hydrocarbon. So what is now the name of this hydrocarbon, children? Yes, butane. Okay, so this you all have learned. So butane. Fine. So, and what is its formula? Its formula is C4H10. Okay. So, now here in this model, I have represented the carbon atom with a green ball and the hydrogen atoms with a black ball, and these are linked by a small stick pieces which are acting like a bond. Am I clear, children? Now, this is a straight chain hydrocarbon. Now, as I told earlier, that carbons can exist in two major forms. One is your chain form and a cyclic form. Now, under chain, they can be a straight chain or they can be branched. Okay, so now let us see how this structure will look when I branch it. So when I say branch, in the sense, one of the carbon group. Now, what is the least hydrocarbon group in a compound, or among all the hydrocarbons? The methyl group. Okay, children. So let us assume now that one of the methyl group I am going to remove. Okay, and I remove and I link it to any of the carbons. Now if I link to the first carbon, it still remains like a straight chain. Fine, either this carbon or this carbon. So where should I attach it to? I can attach it to the second or the middle carbon. So let us just try now that one. So I have removed one carbon from here. Okay, and I have attached to the carbon, the middle carbon. Now when I want to link this carbon to this carbon, how can I link it? By replacing one hydrogen. So from here, I removed one hydrogen. But then, when this carbon is linked to this carbon, only one electron has been satisfied. So that means the remaining also should be satisfied. So hence, it is going to be linked to another 3 more hydrogens. So let me now, okay, I will just place it here, children, such that we can just see the difference. Fine. So now here goes the carbon attached to another carbon. Now this carbon, the extra carbon will be linked to remaining how many hydrogens? 3 hydrogens. Okay, and why it is linked to 3 hydrogens? To satisfy the satisfy the bond. Okay, children. So now if you see now, this has been left empty because the carbon has been removed. That means there is a vacancy here. So who will occupy this vacancy? Yes, the hydrogen. Okay, will be occupied by water, hydrogen. Okay, so now if you see, children, what has happened? Now one carbon from this butane has been attached to one of its carbon. Thereby, no more it is a straight chain, but it is now a branched chain. So, have you observed any difference here? Any difference? Let us start. Let us talk about the difference. Now, first, let us talk about the difference in the formula. Is there any difference in the formula? Let us count. How many carbons? Same as usual. How many carbons? 4 carbons. And how many hydrogens? Same. So, there is no difference between the formula. But then, the difference has come in the arrangement or in the structure. Clear? Now here, this compound can no more be called as a butane. It will be getting another specific name. Now, when it is in a straight chain, we call that as what? N-butane. Okay. But now when it is branched, since in the when it is branched, it is no more having 4 carbons in the straight chain. So that's why it is no more what a but compound, but rather it becomes a compound of 3 carbons. Why? Because there are only 3 carbons. So that means what is its new name now? Its new name is prop, since it all are single bonds. So full name is what? Propane. But then this is also attached to whom? Attached to one carbon compound. Which carbon compound? A single carbon. That's why we call it as a meth compound, methyl compound. Okay, so since a methyl group is attached, its name will be now, its name will be methyl propane. Now, is this name complete? Let us check. No. Now, we have to mention where is this methyl being attached. Now, here, let us count. 1, 2, 3. 1, 2, 3. So, either way when I count, the carbon is getting the position of water second. So, that's why we will, this methyl is considered to be attached to which carbon? Second carbon. So, now the name of this new compound becomes what? 2-methyl propane. What is the name of this new compound? 2-methyl propane. Fine. Okay. But commonly this is also called as isobutane. What is this called as? Isobutane. Fine, children. So now what have you observed? The formula is same. Formula is same, but what the difference has come in? The difference has come in what? In the structure. So that's why these compounds, these hydrocarbons which have same molecular formula but different structure, they are termed as isomers. What are they called as? Isomers. Molecular formula is same, but how they differ in? They differ in their structural, they are different in their structure and other properties. Okay, children. Now let me show the same with by using another model. Now observe this, children. So if you observe, this is a but compound. How can you know that it is a but compound? 1, 2, 3, 4. Okay. So now it's a straight chain. Now what I did, I removed this one carbon attached to the terminal end and I placed it, or I linked it to the middle carbon. Now you see how the structure becomes. It becomes somewhat like this. Fine. Okay. Now can we just compare this structure and this structure to each other? Yes. Okay. So here also what 3 1 2 3. So propane. Then attached to the middle carbon, what is the compound attached? A methyl compound. So that's why 2-methyl propane. Fine, children. Okay. So this is about water isomers. So now let us see with another example.